Alright, year 11s will move on to chapter 14, which is a little bit of review and also going further in trigonometry. With 14A, we're going to look at the unit circle and the four quadrants with the properties related to the circular functions, sine, cos, and tangent. So when you have your unit circle, we always start from 0. We go anti-clockwise. That hits 90, 180, 270, and 360 degrees. You need to, we'll usually tend to use more often radiant notation. Um, and you will start with the going anti-clockwise. Quadrant 1, 2, 3, 4, the same as your Cartesian plane. Um, Quadrant 1 will be your main angle, which is theta. Second quadrant, your angle is pi minus theta. Quadrant 3, to be on the opposite of your theta, is pi plus theta. And in the fourth quadrant, it's if you go all the way around, it's 2 pi minus theta. So you get 2 pi minus theta, and you can also simplify to negative theta because 2 pi is a full period of sine and cos, and also twice the period of tangent. You will have all those properties in terms of symmetry in all quadrants. So for example, here in the second quadrant, sine is the same as sine of, so it's the way it relates, it will relate to circular functions from the first quadrant. So sine is the same, cos is the opposite, and tangent is the opposite. So what it means is only sine of pi minus theta is the same as sine of theta. And there is an acronym when you do A, all station to Craigie-Burn, A, STC. So S here means only sine is positive and cos and tangent will be negative. A means all is the same. They're all positive. Okay. Related to the period, if you had a multiple of 2 pi, to sine and cos is the same as sine and cos. And for tangent, if you had a multiple of pi, you will also get tangent. If I have tangent theta plus 11 pi, you can remove the 11 pi. It's still going to be equal to tangent of theta. Very important is when you have a numerical values here on this side that is greater than 2 pi or less than negative 2 pi, because remember it could be an integer coefficient, could be negative. Always try to remove as many multiples of 2 pi as possible. Just to make the answer, bring it back to the four main quadrants. Ideally, the first quadrant. Negative angle, so it's related to the fourth quadrant. So in the fourth quadrant you have 2 pi minus theta. We remove the 2 pi and we have cos is equal to cos, so it's an even function. Sine of a negative is negative, so it's odd function, and tangent being the ratio of the two is going to be odd as well. There's going to be a negative here. Do you know your exact values? So for angles for theta starting from 0, pi on 6, pi on 4, pi on 3 to pi on 2, which is 90 degrees, you need to remember the values for sine and cos, and also tangent. Tangent is a bit easier, you just do the ratio of sine over cos, okay? So for example, tangent of pi on 4 is 1 over root 2 over itself. It's going to be equal to 1. Complementary angle, it's two angles. So if I have that angle pi on 2 minus theta in the blue arrow plus the yellow arrow theta, that adds up to pi on 2, which is 90 degrees, and 90 degrees relate to complementary. So when you do sine cos of pi on 2 minus theta, it's equal to theta, and you cross over the sine and cos. Okay, so that first formula, those two first formula, you need to know by heart. Okay, It will save you a lot of time to do some algebraic calculation if you know those two, if you have those formula in your head. Okay. If I substitute a minus here, theta by a plus, you get those two respective formulas. So this one will have a negative. Again, it's good to know those ones. Here is the visualization and the proofing. Okay. I'll skip that. If you want to look at the proofing in detail, just look at the textbook. Okay. You can ask me questions during class time. It's a little bit, again, a little bit difficult to explain through the video, considering I have to move on. All right. One example, so you know sine of theta, you have cos, sine of theta equals that value, cos of alpha is equal to that value. Find the value, those values, so you're going to use here complementary angle property with a minus, complementary angle with a plus, and here you're going to use your negative angle properties. And here you will have your answers. Okay, so attempt those questions, very simple question, but just move on to the exercise 14a. And that's all I have for 14A today. So see you later.